In the vast, blue expanse of our oceans, one creature commands respect above all others: the great white shark. A hunter of unparalleled efficiency, its presence strikes fear into the hearts of marine life and awe into the minds of observers. Yet, a curious paradox often presents itself to those who study these magnificent beings. Despite their formidable hunting abilities and constant need for sustenance, great whites are sometimes observed bypassing areas rich with potential prey. It's a behavior that defies our simple understanding of a predator's drive, hinting at a deeper, more complex decision-making process at play beneath the waves. Great whites are built for the hunt. Their powerful tails propel them through water with incredible speed, their jaws are lined with serrated teeth, and their senses are finely tuned to detect even the slightest disturbance. From detecting a single drop of blood miles away to sensing the subtle vibrations of a struggling fish, they are the ocean's ultimate detection system. So, when these highly effective predators choose to ignore a readily available meal, it suggests that their decisions are not solely driven by hunger. Something else, something unseen, must be at work, guiding their ancient instincts. Researchers have documented numerous instances of this puzzling behavior. Off the coast of California, near seal colonies, or in areas known for seasonal fish migrations, scientists sometimes find great whites conspicuously absent, even when their preferred prey animals are abundant and vulnerable. Instead of capitalizing on easy opportunities, the sharks are simply not there. They might be miles away, in less productive waters, or entirely out of sight. This consistent avoidance of what appears to be a free lunch challenges our assumptions about their motivations, compelling us to look beyond mere hunger for answers. The primary drive of any predator is survival, often synonymous with finding food. For great whites, however, it seems survival encompasses a far broader, more intricate set of considerations. Their decisions are not based on a simple cost-benefit analysis of food available, therefore hunt. Instead, they incorporate a multitude of environmental cues, some overt, many imperceptible to human senses. These subtle signals can override even the most powerful urge to feed, steering the sharks away from danger or conditions that, while seemingly benign, are instinctively deemed unsuitable. It's a testament to the sophistication of their innate programming. To understand why great whites avoid certain waters, we must first appreciate the complex sensory world they inhabit. Unlike humans, whose primary senses are sight and sound, sharks navigate their environment using an array of sophisticated biological tools. They perceive their surroundings not just through light and vibration, but through intricate chemical signatures, subtle electrical impulses, and even the Earth's magnetic field. This multi-layered perception allows them to construct a detailed, dynamic map of their underwater world, detecting threats and opportunities long before they become visible to the naked eye. A great white's sense of smell is legendary. Their nostrils, located on the underside of their snout, are not used for breathing but for detecting chemical cues. They can sense minute concentrations of substances in the water, mapping out the presence of prey, rivals, and most critically, predators. A change in the ocean's chemical composition, perhaps the lingering scent of a more dominant predator, or even subtle changes in water chemistry indicating an unhealthy environment, can act as a powerful deterrent. This olfactory map provides an early warning system, guiding them away from potential dangers long before visual contact is made. Perhaps the most extraordinary of shark senses are the ampullae of Lorenzini. These specialized pores, visible as tiny dots around their snout and head, detect weak electrical fields. Every living creature generates a bioelectric field, particularly when stressed or injured, making these ampullae invaluable for hunting. However, these organs also pick up on geomagnetism and minute electrical disturbances in the water, such as those caused by underwater geological activity or shifting currents. An area with unusual electrical signatures might register as unstable or dangerous to a shark, prompting an instinctive avoidance. Beyond chemical and electrical cues, great whites also possess an innate ability to perceive and utilize the Earth's magnetic field. This magnetoreception acts as a biological GPS, allowing them to navigate vast oceanic distances with remarkable precision. Research indicates that sharks use these magnetic lines of force as invisible highways and waypoints during their long migrations. The magnetic field provides a consistent, global reference system, essential for orienting themselves in featureless open water. This ancient navigational ability is deeply embedded in their biological makeup. If great whites use magnetic fields for navigation, it stands to reason that anomalies or disruptions in these fields could signal trouble. Areas with unusual magnetic signatures, perhaps caused by geological fault lines, deep-sea vents, or concentrated mineral deposits, might be perceived as unstable or dangerous territory. Such anomalies could disorient a shark or trigger an innate avoidance response, much like a broken signpost on a familiar road. Even if prey is abundant, the conflicting or unfamiliar magnetic data might prompt the shark to seek more stable, predictable environments, where their internal compass works reliably. A great white's decision to avoid certain waters isn't just about detecting specific threats, it's also about an innate, deep-seated caution towards the unknown. Areas that lack the familiar cues of safety, or perhaps emit a general unsettling sensory profile, may be instinctively avoided. This protective mechanism is vital for survival. If an environment feels wrong, too quiet, too active with unfamiliar signals, or simply out of sync with their expectations, the shark's inherent programming will guide it elsewhere. This goes beyond rational thought, it's an ancient, non-conscious calculation of risk. While formidable, great whites are not without predators. The orca, or killer whale, stands as the only known significant threat to adult great whites. Orcas are highly intelligent, social hunters known for their coordinated attacks. They actively hunt great whites, often targeting their nutrient-rich livers. The presence of even a single orca, or the telltale signs of an orcapod, is enough to send great whites fleeing from an area. This is not a perceived threat, it is a very real, deadly danger that great whites are deeply programmed to avoid. Observations have shown that great whites are incredibly quick to respond to the presence of orcas. Following an orca attack on a shark, or even just repeated sightings of orcas in a particular region, great whites have been documented to completely abandon those hunting grounds for extended periods. This isn't just a momentary retreat, it's a significant shift in behavior, suggesting a form of learned or ingrained avoidance. Their survival programming prioritizes escaping the orca threat above all else, even if it means sacrificing prime feeding opportunities in the short term. The risk is simply too high. The deterrence caused by orcas isn't just about direct encounters. Even after an orcapod has moved on, the lingering shadow of their presence can keep great whites away. This shadow consists of residual cues, the faint chemical traces left behind by orcas, the sounds of their calls that can travel vast distances, or even the subtle disturbances in the ecosystem from a recent hunt. Sharks are highly sensitive to these persistent environmental signals. These lingering indicators act as continuous warnings, reinforcing the message that a particular area is unsafe, even when the immediate threat is gone. Beyond predators, great whites are also acutely sensitive to the subtle chemistry of the water itself. Changes in parameters such as oxygen levels, salinity, or pH can signal an unhealthy or unstable environment. For example, sudden drops in oxygen, often associated with upwellings or algal blooms, can create dead zones that are unsuitable for most marine life, including sharks. While there might still be some prey struggling in such conditions, a shark's innate physiological programming would compel it to avoid these areas, recognizing them as detrimental to its own well-being and long-term survival. Sharks, like most marine creatures, are highly sensitive to water temperature. Each species has an optimal temperature range for its metabolic functions, hunting efficiency, and overall comfort. Great whites prefer temperate waters, and sudden temperature gradients, such as a cold upwelling from deep waters or an unusually warm surface layer, can deter them. Even if food is present, an area outside their preferred thermal comfort zone can trigger avoidance. Their biological imperative guides them towards conditions that optimize their physiology, ensuring peak performance and long-term health, rather than just immediate caloric intake. The underwater world is not silent, it's a dynamic soundscape. Sharks, with their acute sense of hearing and detection of vibrations via their lateral line, rely on these sounds for navigation, hunting, and avoiding danger. However, human-generated noise pollution, from shipping traffic, sonar, seismic surveys, and offshore construction, can overwhelm this natural soundscape. This constant cacophony can disrupt a shark's ability to interpret vital environmental cues, disorienting them or signaling an unhealthy environment. Even if prey is plentiful, the incessant, unnatural noise can prompt them to seek quieter, more pristine waters. The ocean floor is a geologically active place. Earthquakes, underwater volcanic activity, and natural gas seeps are common occurrences. These phenomena generate specific seismic signatures and release chemicals that great whites can detect. Unusual underwater tremors, subtle pressure changes, or the release of gas bubbles from the seabed might register as signs of instability or impending danger. Such natural geological events, though not directly threatening in every instance, could trigger a deeply ingrained avoidance response. The sharks are programmed to react to these primal signals, prioritizing safety over an easy meal. Ultimately, the great white shark's decision to avoid certain food-rich waters is not a conscious, deliberate choice in the human sense. Instead, it's an intricate, rapid, and deeply instinctive calculation performed by their ancient biological systems. Their brains integrate a constant stream of sensory data: smell, electroreception, magnetic fields, temperature, pressure, sound, and compare it against an innate library of safe and unsafe environmental profiles. If the composite sensory picture signals an unacceptable level of risk or physiological stress, the automatic response is avoidance, regardless of the immediate availability of prey. This sophisticated, non-conscious decision-making process is a testament to the ancient wisdom embedded within these magnificent creatures. It reflects millions of years of biological programming, finely tuned to ensure survival in a dynamic and often perilous environment. Their avoidance of danger, even when it means passing up an easy meal, highlights a profound understanding of risk that transcends simple hunger. It's about conserving energy, minimizing exposure to threats, and maintaining optimal physiological conditions for long-term survival, not just immediate gratification. The enigma of great white sharks avoiding food-rich waters serves as a powerful reminder of the ocean's profound complexities and the incredible adaptations of its inhabitants. We are only just beginning to decipher the full extent of their environmental sensitivity and the subtle cues that govern their world. Each new observation deepens our appreciation for their intricate biology and the ancient, instinctual knowledge that guides them. The great white remains a creature of mystery, navigating unseen depths and responding to whispers we are only now learning to hear, reminding us how much more there is to discover beneath the waves.